Hi everyone, this is section 1.5. This is getting into some equation solving. And I want to point out here that by the time you reach this point in your mathematical career, we assume that you can solve equations. So that's not really what I'm teaching here, okay? I'm trying to teach you some tricks for some more complex things that are going to start showing up in equations and some ways that maybe you hadn't thought of before that might make your life a little easier. To approach an equation like this. So while I'm doing this, there may be some times that you say to yourself, well, I would have done that a different way. That's totally okay. But you may run into some situations where, this way that I'm showing you could help you. Okay? So I would write them down the way I'm doing them here. And then when you're doing them on your own, if you have a different way that works better for you, A-okay. Okay? So with this first equation, first, I guess, equation solving in general, we know that PEMDAS is the order that we do math in, right? We use order of operations when we are evaluating expressions, when we're doing math. But equation solving is all about undoing the math, okay? It's all about working backwards like this, okay? So as you're undoing the math, the first thing you always want to get rid of is any addition and subtraction. Okay, anything added or subtracted. And then you want to get rid of any multiplication or division. Then we're going to get rid of exponents. And then if there's anything in the parentheses, we kind of have to start all over again. Okay, we come back here with whatever's in the parentheses and work through that. Okay, so like in this first one, if I'm trying to get the x by itself, the first thing I want to get rid of is anything being added or subtracted. So like this 7 here, I would subtract 7 from each side. Okay, and we end up with 2/3 x equals 12. Okay, and then probably many of you are saying, well, then I would just divide by 2/3. And with calculators, dividing by 2/3 is pretty easy to do, okay? But if you're in a situation where you don't have a calculator, or if you are going to type it in your calculator incorrectly, there's actually a better way to get rid of that 2/3. And that would be multiplying by the reciprocal, okay? And the reason I say that that's better is really if you were to say that you were dividing by 2/3 on each side, the way you divide by fractions is multiplying by the reciprocal anyway. Okay? And then here, if you were without a calculator, this is really just 12 times 3 divided by 2. So that'd be 36 divided by 2, which is 18. Okay? And so again, the point there was how could you get rid of the 2/3? And if you divided by 2/3 and it worked out okay for you, that's totally fine, okay? But you may run into some situations where multiplying by the reciprocal works out better. Okay, this next one has multiple fractions in it, and I don't know about you, but I don't love fractions. In order to work through this one, we would have to find common denominators, and then we'd be stuck with fractions all the way throughout. So I'm going to do something called clearing the fractions, and I'm actually going to write that down here because when I refer to clearing the fractions later in class, I want you to be able to refer back to this example, okay? The way you clear the fractions is you still start by thinking about what do 4 and 2 both go into, okay? What could they both divide evenly into? Similar to how you would find a common denominator. So here I would say 4, right? These could both turn into a 4, both divide evenly into a 4. But instead of rewriting the fractions, I'm going to multiply the entire equation by 4, okay? And the reason I'm doing that is watch what's going to happen now. If I multiply this x by 4 and then divide it by 4, really my 4's are just going to cancel, and that's going to turn into just a regular x. And then if I distribute and I multiply over here by 4, then I would do 4 times x and divide it by 2. Well, then 4 divided by 2 is just 2, so this would become a 2x. Okay, so just off to the side, let me write what that would look like. That would look like this, 4x, and then you'd have it divided by 2 when you multiply by that 4, and then that's where the 2x comes from, okay, because 4 divided by 2. Now, this is all fine and good, and I really like the way this is looking right now. You just have to remember that then you have to multiply this negative 15 by the 4 also. So 4 times negative 15 is negative 60. And now this is a much nicer equation because then I can just combine these two and make them a 3x. So 3x equals negative 60. And then I can divide by 3 on each side. And I end up with x equals negative 20. Okay, so that's called clearing the fractions. That's where you multiply by something first to get rid of all the junk on the bottom. And then you come out with an equation that doesn't have any fractions in it. Okay, number 3. Probably a lot of you look at number 3 and the first thing you want to do is distribute that 3. And that's not a terrible idea. Okay, distributing the 3 would work just as well here. But I want you to remember also that this is multiplication here, right? This is 3 times 2x minus 1. And so if that's multiplication, I could get rid of it by dividing, okay? Which means I have to divide over here as well. Now, I don't have to go in here and divide these by 3 because this is all being multiplied together, which means I can just divide it once and get rid of it. This is like all one term, okay? And so dividing this whole thing by 3 just cancels these. And then I'm left with 2x minus 1 equals negative 5. And then from here, I bet you'd be okay. Add 1 and add 1. So we end up with 2x equals negative 4. I'm just going to carry that on over here. Okay, divide by 2, and we end up with x equal to negative 2. Okay, moving on. Number 4. Now, I just showed you that great trick with number 3, and in number 4, I'm going to tell you that it won't work for us because we can't divide by this 4 because this one has a different number sitting out in front. Okay, we probably could figure out a way to get away with dividing by 2, but I think that'll be messier. So on this one, I am going to just distribute here. Okay, so 4 times 3x is 12x, and 4 times negative 2 is negative 8. 2 times 6x is 12x, and 2 times 5 is 10. Okay? Okay, now from here, and I think this depends on how you were taught to solve equations originally, but generally from here, I always start by moving my x's around because I like to be able to control which side my x's end up on, and then I take care of like the 8 and the 10. All right, but some of you I know have been really ingrained to just add that 8 right away, okay, to the other side. Totally up to you, but you will always see me move the x's first, okay, and you're going to notice something weird here. So if I want to move this 12x to the other side, I would subtract 12x and subtract 12x. Now this is going to cancel so that I have negative 8, and normally I would have some x's left over here, but in this one, my 12x also cancels on this side. Okay, that's kind of a weird thing, and I'm left with a 10. Now, I want you to look at that. I don't have any x's left. In what world is negative 8 equal to 10? It's not ever, okay? And this is, since this can never be true, that means there's no value of x that's ever going to make that thing be true. And so for this one, we would say we have no solution. There's no possible value of x that would make that work. Okay, so that was the weird thing with number 4. Let's take a look at number 5 here. Number 5 is kind of gross. Quite honestly, I would probably start, remember my sad map thing up there? I would start by moving this 4 to the other side. So I'm going to add 4 and add 4 to the 2. Notice I'm not adding it to the 4x because that one has an x on it. They're not like terms. Okay. 12x plus 18 over 3. And now this equals 6 plus 4x. Now from here you could do one of two things. You could divide both of these by 3, okay? That's not always going to work for you because if these numbers up here don't divide nicely by 3, that probably isn't the way I would go. Or I could think about how do I get rid of a division by 3? Well, I would probably multiply this whole thing by 3. But just remember that means I multiplied this whole thing by 3. So over here on the left, my 3's cancel. Okay, and I'm going to rewrite over here. That's going to leave me with 12x plus 18 equals, okay, and then if I distribute my 3 over here, I end up with 18 plus 12x. Okay, are you noticing anything weird here? All right, watch what's about to happen. So, like I said, my next step would always be to get rid of my x's. So I'm going to subtract 12x and subtract 12x. They both cancel out again, just like they did back here. That doesn't always happen, but they did in this case. This time I'm left with 18 equals 18. Okay? Well, that's always true, right? And so what that really means is that any value of x I find here could make this equation true, because this is true 100% of the time. Okay? So instead of no solution here, what I'm going to say is my answer is all real numbers. That means that x can be anything. Okay, x can be any number I want, and it's still going to make 18 equal 18. Okay, so when your x's drop out of the way, all right, when both of your x's disappear, you're always going to be in one of these two situations. And what can tell the difference is if your two numbers come out the same. Oh, sorry, these ones are different. If your two numbers come out different, not equal to each other, or the same as each other. Okay. Okay, I will do a second video for the word problem examples on the back, but that was really what I wanted to cover in terms of equation solving here.